When we're young, we might have dreams of living in space or becoming a train driver. But for Leopold Kronecker, his Jugendtraum, or dream of youth, was to have a different way of writing all the algebraic numbers. And this was also Hilbert's 12th problem. And Kronecker did make progress on this problem. Let's remind ourselves what an algebraic number is first. So an algebraic number is a number that you can write as a polynomial, so x squared plus 2x plus 1 equals 0. The root or solution of that equation, or the x, and there might be more than one solution, that is an algebraic number. So if you write a number like that, then it's algebraic. If you can't write it like that, by the way, it's transcendental. And so algebraic numbers go beyond the rational numbers because you can't write root 2 as a rational number. But you can write it as the solution to one of these algebraic equations. But what Kronecker and what Hilbert wanted were other ways of writing these. Instead of having to write these polynomial equations, could you do it in another way? And Kronecker showed that for the algebraic integers, yes, you could. So an algebraic integer is just any one of these kind of equations where the first term has a coefficient of 1. So for example, x cubed plus 2x squared plus da-da-da-da, that's a representation of an algebraic integer. But if it started 3x cubed, it's no longer an algebraic integer. So Kronecker solved that problem. But what about all the other algebraic numbers? Is there some way of writing those? And by the way, I should say the way that Kronecker solved that problem was he showed that you could use exponentials with imaginary powers. And you might know that these kind of correspond to sine and cosine functions, and they also correspond to the roots of unity, including the imaginary square roots of 1. So Kronecker showed that you didn't need to use algebraic equations, or polynomials rather, to express the algebraic integers. You could just use these e to the I, pi, etc. equations. But what about all the other numbers? Well, that's a work in progress. It's not solved. People are still working on this. There has been progress beyond Kronecker's work for quadratic algebraic fields. This has been solved, and for some others too. But this is very much an open and very, very difficult problem. So Kronecker's dream of youth remains alive.